Cool. So I'm going to be presenting about, I guess really this is a talk about A2A, a technology that underpins lots of agentic services and things like that. I've been playing around with the technology recently quite a bit, sort of deploying it into production workloads. And what I wanted to do is share some of my learnings as I've been playing around with it. We're going to look at how you can build flexible systems of using A2A so that they can self-organize and kind of fulfill some intent. So really it's a tech presentation. There's going to be a bit of a live demo, which fingers crossed goes okay. It's going to be using LLMs, which are known for being a little bit unpredictable, so we'll see how it goes. Roughly what I'm going to be going through, I've got some quick definitions, so some concepts and how my mental model, what some of these things are, what A2A is, what I mean when I say agent services, and sort of set a baseline for us to go from. I'll do a quick live demo. I've got a kind of hopefully a scenario that everyone can relate to, so a team of engineers firing questions at them, and they'll work together to sort of resolve that example. Then I'll go through what's underpinning that demo, talk about some of the technology that's underneath it, explain how it works, and then I'll talk about what you should be considering if you're looking to build your own systems of agentic services. So before we get started, I'll quickly introduce myself. So my name's Adam. I work for a consultancy based in Sheffield, Leeds and Manchester called Nimble. I've had the pleasure of working with many people in this room over the past 8 years or so, former bosses, Tim, colleagues, past and present. So it's nice to be stood here presenting and sharing things back to the community. I'm a bit of a jack of all trades, kind of touch all sorts of different technologies, platform, cloud, AWS, Azure, full stack engineering really. I'm a bit of a tinkerer, and really this is me sharing some of that tinkering back to people, so appreciate it. So what is A2A? I don't know if anyone's heard of A2A before, but it's a protocol, a framework, a set of SDKs, a set of tooling that was introduced by Google maybe about a year ago, and it's all about enabling agents to communicate to each other. So you might build an agentic workflow, and you might sort of self-contain it in its own little bucket. But A2A is there to make enable you to break that thing down into different systems and services so they can talk to each other. It's really focused on interoperability and communication. It kind of supported by, you can use your SDK in Python, Go, Java, whatever, it's a standard and a protocol first, and it's supposed to be as flexible as possible. So you can kind of adapt it to your own needs. And when we're talking about self-organizing teams of agents, communication is really, really important. How these things actually interact with each other is kind of the crux of the problem there. So when I talk about agents, really I'm talking about two things. It's a service at its core that takes on work for a user, fulfills its intent, and you can think of an agent like you would think about any web service or API or system. It takes a request from somewhere, does some work, produces the result and passes it along. The difference really with an agent service compared to other systems is they make use of models and tools and LLMs, and they might typically make use of workflows to fulfill that intent. By leaning on LLMs to sort of reason and guide these workflows, you can create systems that are incredibly flexible, and they don't need to be incredibly complicated either. You can create simple services that you don't need to give them perfect inputs to still get something reasonable out the other side. But like any web service or API or system, you still need to think about solution design and architecture and how you structure these types of things. You can pile lots of stuff into a single agent or a single service, and it can start to perform really, really badly. If you give it too much context, it starts to lose that context. It starts forgetting about it. If you give it too many tools with ambiguous definitions, it struggles to kind of work out how it should approach using those tools and how to address those problems. And I guess importantly, it can also make them harder to maintain. At the end of the day, these are still systems that an engineer has to work with. And like any system, you need to think about architecture, performance, scale, security. I think there are lots of rabbit holes to go down with this type of a thing. So it's probably going to be quite, relatively high level. And what I hope people kind of take away from this are topics of further interest that they can go and explore after this. A2A can help with that kind of bloating type of problem by making it easier for agents to communicate and focusing on the communication problem. You can start to break down that monolithic service into something smaller, more bespoke. You can kind of think of agentic solution design, how you might think about service-oriented architectures or microservices. A2A provides you with a means of running agents and enabling them to talk to each other, and that means what you need to think about as an engineer or an architect or someone in solution design is how you start to separate those concerns. What capabilities make sense to group together? How do you test, scale, and extend those sorts of services? So, quick introduction to a couple of things. Now I'm going to shuffle around some screens. All right, can everyone, I'm going to zoom in. Can people at the back read that? One more. Is any better? Or bear with me. All right, so what we're looking at here is a demo application. It's a chat interface that lets you interact and communicate with a set of agents. So in the middle, we've got a chat prompt like you might find on any basic system. On the right, we've got a list of engineers or members of a team. And what this is a demo of is, a typical work environment. A request comes into a team, and the request might go to a person that isn't necessarily the best one to respond to it. What these agents are doing is they're going to work out, well, who's on my team and who can I share it with? So we've got Adam, we've got Rob, we've got James, we've got Andy, we've got Will. I'm going to talk to James, the delivery lead. I'm going to ask him a question about something, and this is an agent running in the background that will make use of LLMs and kind of farm it off to the right thing. So in theory, if I hit send on this, it's gone to James. James has done some thinking. He's farmed it off to his colleague who's doing some more thinking, and then he's summarized the results. So if I go back to the top, I've asked James, the delivery lead, can you help me with this really challenging problem of center aligning a div using Tailwind? James is an AI agent that's got prompts, he's got LLMs, he's got things that he can do, he's got skills. What he doesn't have any skills in is front-end design. He doesn't know how to work with Tailwind, and but what he can do is interrogate his team, who is available to him, and find the right way to go. So James has said, Will, lead front-end engineer, can you help me respond to the following query? And then that's kind of being routed off to the right engineer. So that's gone to Will, who's provided a response. Absolutely, Will's a front-end engineer, Tailwind's in his bag, there's something he can help with. And he's given a prompt and stuff. I don't know if anyone knows Tailwind or is a front-end engineer themselves, but this looks broadly okay to me. He's kind of given some helpful things. Then at the end, James has gone, Will, that was great, thanks for helping. He's wrapped up the conversation and then he's moved on. So what we've done is fire off a request to one agent that's running locally on my machine, talking to Bedrock within AWS. That agent's gone, I don't know how to help you, but I know who can. He's passed it along. That agent's fulfilled that request, and it's kind of gone there. I appreciate the requests themselves are relatively simple. This is a demo with inter-agent communication here, so I could have put anything in there, and in theory, the agent would go farming off. On this side, I've got a more complex question. I've got a front-end question for Node. I've got a back-end question for Java. In my Node front-end, how can I turn a string to uppercase? Everyone's doing that all of the time, I'm sure. And in my Java backend, how can I make that string lowercase? If I send this question off to James, the delivery lead, again, he's not a front-end specialist, he's not a back-end specialist, but what he can do is find out who's on his team. And coincidentally, we've got Andy on this team as well, who is a back-end engineer who does work with Java, a standard issue, grumpy senior engineer specializing in all things Java, who can help. So I hit send. It's the same sort of process again. That request has gone to the delivery lead. The delivery lead's gone, I can't answer this, but I know who can, and they're kind of going away. So if I scroll up to the top, we've got James, who's asked Andy to solve to address the Java question. He's asked Will to address the front-end question. Will's gone off and done some thinking, and he's come back with a response. And then Andy's done some thinking and come back with a response. So what's worth calling out here is, I haven't hard-coded anything in with these agents. I've not said, James, these are the agents that you got to work with. If you get a front-end question, go talk to this guy. If you've got a back-end question, go talk to this guy. These agents are using A2A to kind of explore what's out there and kind of rationalize themselves what they should be dependent on. So I'm going to swap back to slides. Whoa. So behind the scenes, A2A is kind of doing a lot of the magic for us. So there are 3 things that A2A is implementing for us that are really important for how that demo works. The first one is the agent card. This is ultimately how an agent is describing its capabilities to other agents and anything else that wants to consume those services. In our demo, all the agents within the same system, but in theory this could be third-party systems. You could be consuming systems from somewhere else. The agent card is what lets an agent advertise its skills and capabilities to other things. There are tasks. This is A2A's way of managing workloads. So if you've got a long-running service that runs for hours, you might want to stop, start, however you manage that. You might fire multiple requests at a service multiple times. Tasks are how it will kind of run those behind the scenes. And then you've also got messages. So a means of structuring communication between those different agents. It's kind of agnostic in format. You can work with JSON data, you can send images, you can send videos. A2A itself doesn't necessarily care, it just provides the standard envelope that is used to pass things back and forth. Ultimately, I'd view A2A as an agent wrapper. It wraps agentic workflows so that you can build a service that you can deploy and scale independently of other things. So in our demo, there were a few components. We've got the user, which in this case was me. We've got the web app, which was the thing that you guys could see. What you couldn't see behind the scenes was a set of agent containers that were running. So we had 5 agents. And alongside those agents was something that, a little agent registry. So these agent containers are just Docker components, Docker containers really, that I'm just running locally on my machine. You could deploy those wherever you want to, into ECS, into Azure, or whatever. A2A itself doesn't care. You'll find, if you're looking at Amazon's offerings, an Agent Core or Azure's AI Foundry, they support A2A as well, where you can deploy those services into that stuff. So if you want to kind of deal with agent communication, you might consider Agent Core as a managed service for that. But if that's not available to you and not an option, you can use it wherever suits your needs really. So 5 agents and an agent registry. All of those things apart from the agent registry are using Amazon Bedrock. So Amazon Bedrock is the LLM provider in this example. I'm just making use of the Amazon Nova models because they're relatively small, relatively quick, relatively cheap. So they're not doing anything complicated in this example. But A2A, again, doesn't necessarily care what LLMs you're using. In theory, you could hard code just a hello world response. A2A is just there to execute that kind of workload. In our example here, we're using LangGraph behind the scenes, so we've got an agentic workflow itself implemented, wrapped with A2A, integrated with Bedrock. So inside of one of these agents, you've got an agent card. What is it? What can it do? What are its skills? Where can someone find me if they want to find me? In what way do I like to be communicated with? What's my preferred communication mechanism? You also have a set of tools which are structured code that an agent can make use of to kind of perform workloads. And then you've also got an agent executor, so the thing that triggers the tasks and actually executes it. So I'm just going to go through each of these one by one, give some examples so you can see what it looks like. So the agent card. So this is agent Andy's agent card. I appreciate the back. You might not be able to read that, so I'll kind of go through it as well. But within an agent card, there are a few key things. You've got the name of the agent, you've got a description of the agent, you've got the capabilities of the agent, and the self-described skills of the agent. The agent card also defines how the agent wants to be communicated with. In this case, it's JSON RPC, and it can be invoked from a particular endpoint. So this is just a little screenshot of the code. There's an agent card interface that is kind of having plain text passed into really. The persona for the Andy agent is this. It's got a description of standard issue, grumpy senior engineer, is an expert in Java 8 to 21, Spring internals, relational databases. He'll resolve your back-end architectural failures, but will also complain about the decline of engineering standards. So when we look at all of the responses for the Andy agent, if I go back to the demo, you'll probably see at the end, he's helped, he's answered your question, but he's been a bit miserable, and he's demanding logs or to go away. What we've also got a set of set of skills and tags and metadata that kind of go there. So what I showed was a persona, the prompt. So your agent had a description, a personality. You are a senior Java engineer. This is what you do. What the agent card also has is a set of skills, which are essentially metadata that describes the type of thing that it can do. So in our example, we've got some key tags. If you're asking an engineering problem, a question, a backend question, or something to do with Java or JV optimization, this agent card lets you kind of route traffic there. It also gives you some examples of how the types of problems it can solve. So an example, if you're given an input of how can you help me scale this Node.js API, the output would be first you should admit that as a mistake and then move on from there. And that will help the LLMs that are sort of routing traffic between different agents. It'll help them decide which agent should we move on to. So if I'm asking a Node.js question, I probably don't want my question to go to someone that absolutely hates Node. I should go to someone that is more amenable to that. So that was the agent card, how it describes its capabilities. Then we've got agent tools. So in our example, in our demo, we only had 2 tools really. So there were 2 tools let us kind of build this seemingly complex system of emerging behaviors. One tool was an ability to see what agents existed. The other tool was an ability to ask an agent a follow-on question. So I mentioned we've got this agent registry. That agent registry is essentially just a listing of agent cards. So when I start up those services, each agent just goes, this is where you can find me, this is my agent card. And what we've done for each individual agent is right, what exists, what comes there. So this keeps the system flexible so we can add more capabilities as a system without needing to update every agent. That comes with other drawbacks and things to think about, but for this demo was quite nice. The Ask an Agent tool, that's just there so that once it's found the agent it wants to talk to, it can interact with it. So looking at one of these tools, it's really simple. It's code. It's like it's predictable, testable. It's going to do the same thing every single time. Where the flexibility comes in with tools is making sure it's called and selected in the right way. So in this example tool, it's just list available agent, makes a request to get agents from the agent registry. It filters itself out of that because the Andy agent will be in there, and then otherwise just returns a list, a JSON document back that can be further processed. So the last thing that's important within one of these agent services is the agent executor. So a request comes in, and what you get with A2A, if you're making use of its SDKs, is essentially a server that runs. The server has an agent executor, which is there responsible for managing the execution of a single agent run, as well as the different tasks. So it lets you stop, start, run, pause, resume. There's memory and kind of state that these things are able to kind of look after. The agent executor is what sort of passes that back and forth. And I think I mentioned it a second ago, but the agent executor in A2A itself doesn't care about whether you're using Crew AI or LangGraph or whatever. You could hard code this flow yourself. It's not there to solve implementing an agentic workflow necessarily, just running and helping them communicate with each other. So also in our demo, I think it's there are a few different patterns of how you might orchestrate these different systems of agents. So in our example, we had every agent able to talk to every agent. We had an agent registry in the middle of it, but that might not necessarily be the right thing for everyone. I think it's very flexible, but does come with some trade-offs and drawbacks. To the right, there are a few other examples. I think you probably see like the orchestration pattern quite a lot. There's an entry point, a single place that agent communication goes into, and that does the delegation out to other systems and services. But again, that's not the only one. You could have linear workflows of agent services where you hard code the flow between the system. And really it's about what use case is appropriate for you and then picking the right pattern that addresses your problem. So in our system, we've got me asking a question, goes into a web app. In this diagram, we're firing that directly at agent Andy. I've asked a question about centering a div. We've looked at agent Andy. He's a Java engineer, not a front-end engineer. What he's going to do behind the scenes is make use of an LLM to evaluate whether this is something he can respond with. The LLM will kind of then direct the agent where to go next, and ultimately it'll go, okay, you can't answer this question, find out who can. Use a tool to go find out who can answer this question for you, which is the agent registry. So we've got agent Andy using a tool to list other agents, which goes to the agent registry, which has all the other things registered underneath it. What happens next is that agent Andy will then delegate that request off to the agent that is selected. So you'll make use of the call agent tool. So my request that's gone into agent Andy gets passed on to agent Will, who will in turn go through that same workflow. Is this a question I can answer? Yes, in this case it is. So I'll generate a response and pass that all the way back through. And that's kind of it from a demo perspective. I guess the next question is when might you need to consider using A2A? If you've got complex agents that you think could be decomposed, and maybe A2A is a technology that works for that. If you've got multi-agent, long-running workflows, it helps address that problem. It lets you think about solution design a little bit more. It lets you break the problem down. If you're working with unpredictable patterns of data, you might start to think about building out workflows of systems. Unpredictable data could come from all sorts of things. We've been working in the cyberspace where the data we're processing is best endeavors. We have to do something in response to it, but we don't necessarily know what we can do for any given response. So the system that we've been developing is flexible enough that it can deal with missing data and deal with different types of data and farm it off to the different, apply the different strategies that it needs to in order to address it. A2A, I guess, if you need to think about extensibility of your systems and how you expand the capabilities of that system over time, A2A is a good tool or a technique or a technology to apply to that. In our example, with the agent registry, we could just drop in another agent whenever we want. It would be discovered. I'm sure there are better techniques and things you could apply to it, but in a service discovery type of way, it helps keep the system extensible. I think another thing that's worth calling out as well, a learning that we had here is AI services are patchy globally. In the UK, in the US, are pretty good. They're all right. You can find most LLMs that you need available to you. But if you're off, for us it was the Malaysian region working in AP Southeast 5. There's pretty Wild West. There's not much available to you. You had access to some of the Nova Pro models, but Bedrock, an agent core specifically, was way less mature within that region. So we had to go look at, well, okay, we want to make use of LLM services within that region because we're working with sensitive data, regionality is important. We needed a platform agnostic way of kind of doing that because we couldn't make use of managed services to do so. To summarize, I would think of A2A as a communication and enabling technology. It's not there to implement your workloads for you. It's just there to make it easy for you to run them. Designing a system of agentic services is still system design, and you still, the same baselines of good standard engineering apply to that. How does the system need to scale? How do I keep the system secure? How do I ensure the system solves the right problem? By breaking down our agents into smaller workloads, we can scale those up as we need to. We've got different, these are containerized services. Maybe one set of agent services is under more load than others. We can scale that up independently of everything else. The security aspect's quite important. I think by opening up these agents to communicate with each other and the self-discovery thing, that's actually, there's quite a lot to think about there before you kind of move that into a production workload. If someone else got access to that agent registry and plugged in some malicious agent, suddenly it would be available in our example. So there is a bit of risk involved. And I think it comes up quite a lot is, what are the use cases that agentic AI is appropriate for us? I think that's still, in the industry, you see that quite a lot. AI is a big buzzword. And I think people are still trying to work out when is it appropriate. Because it might not necessarily be the right thing for you guys. And I think finally, self-organizing systems can take many different shapes and forms, and depending on the pattern you apply in ours, every agent can talk to every agent. That's really unpredictable. But if you need more predictability, there are different patterns you can apply. The more linear workflow might be right for you guys. Yeah, thank you.